Hello and welcome to another episode of the Williams Learning Lab. Today we're on the topic of atomic structure, specifically average atomic mass. What is it? Why is it important? How do we calculate it? Let's get started. So when an element is mined from the Earth, it contains a mixture of isotopes. Well, we know that isotopes have different masses. And it's really important in chemistry that we are able to measure things very accurately and precisely. So there needs to be a way to accurately measure the mass of the substance considering the mixture of isotopes. We do this through average atomic mass. I abbreviate it as AAM here. And what this is, it is the weighted average of the atomic masses of all naturally occurring isotopes of an element. So don't get lost in the verbiage here. We'll simply show you what that is. But first, here's an example of an isotope variation in nature. There are two isotopes of copper, copper-63 and copper-65. Copper-63 makes up 69.15% of copper on Earth and has a mass of 62.930 atomic mass units. Copper-65 makes up 30.85% of the copper on Earth and has a mass of 64.928 atomic mass units. So now, how can this be used to accurately determine the mass of a copper sample? How can we calculate this atomic mass, this average atomic mass? Well, here's an example. We are tasked with finding the average atomic mass of copper. And so what we have here is we have copper-63. It has a precise mass of 62.930 atomic mass units, and it has an abundance of 69.15%. Okay, copper-65. It has a precise mass of 64.928 atomic mass units, and then the abundance of 30.85%. To find the average atomic mass, what we're going to do, quite simple, we are going to take the mass of the copper-63, 62.930, and then we're going to multiply it times its abundance. And we're going to put that in decimal form. So 0.6915. And then we are going to add we'll add the product of the mass and abundance in decimal form of copper-65. So we have 64.928 atomic mass units multiplied by, put it in decimal form, 0.3085. And so when we put that into a calculator, what we're going to get is the average atomic mass of copper. And that turns out to be 63.546. And that is atomic mass units, or grams per mole. Sometimes atomic mass unit is just abbreviated with a U. This is quite simple. Just multiply the mass times the abundance and then add it to each subsequent mass and abundance of the isotopes that are provided. I hope you found this tutorial useful. If you appreciated the content, would you please consider commenting, and subscribing? And until the next episode, have a nice day.